We're continuing with the law of signs, but we talked about this word before. Do you remember that crazy word, Dallas? You just said it. What do we call it? The ambiguous.
Thanks, Gene.
Ambiguous case. All right. Which basically means this. Watch. You've been doing a little bit. Well, actually, have you done any problems with law of signs yet? Because I think what I assigned was just.
You just assigned area.
I just assigned the area stuff, right? I was thinking. Let me speak. I was thinking when I assigned that it had some law of sign stuff on there, but I guess it was just the area stuff. But I did ask you to go back to that law cosine lesson, right? In Dallas, that's why I didn't collect it. So 13.5 was the law of cosines. When I'm talking about this ambiguous case, there's basically three possibilities that you could have when you use the law of signs. Okay, this is only true on the law of signs, and also it's only true now if you have. Forget that. I'm going to go to something else. When we talk about the ambiguous case, we're talking about there are times when you get one answer, all right, which is a normal, I guess if you want to call it normal. That's a normal type of an answer, just getting one answer for the angles and the sides. But there's also times when you get 0 solutions. You could get one solution, like we talked about, and you can also, there's situations where you can get 2 solutions, all right? So when do you know you're going to get no solutions? When do you know you're only going to get one solution? And when do you know you're going to get 2 solutions? Well, I'm glad you asked, because I just happen to have a thing right here. This is right in the book. It's on page whatever, 834, okay? I just grabbed it from the screen and put it up here. Here's a situation that we have. Now, there's a lot of stuff going on right here. We're going to take one a little bit at a time, all right? The first example we're going to do is an obtuse triangle. So if you look at it, we're going to, I should say this. Let's talk this. We have possible triangles in the side-side angle case. What in the world does that mean? Well, when we talk about side-side angle, we're talking about having 2 sides and an angle. There are situations where they'll give you 2 angles and a side. You don't have to worry about the ambiguous case when it's 2 angles. When they give you 2 angles and a side, you don't have to worry about there being an ambiguous case. There's always going to be just one solution. All right? So you're free and clear. You can just do the law of signs, no big deal. It's when you get 2 sides and an angle, that's when it gets a little bit weird. Sometimes you get no solutions, sometimes 1, sometimes 2. All right? And this chart kind of this does help you out a little bit. It's hard to understand at first, but we'll take it a little bit at a time. Let's go back and to this, and let's start with an example. We're going to start with an obtuse triangle, and we're going to see, is there 0 solutions, 1, or 2, and then we'll go on to try to solve for it. So let me draw the triangle up here. Okay, here's my triangle. What do they give you now as far as the information? They give you one angle, right? And they give you what? 2 sides. So if we go back to that, and let's take a look at the 2 sides, because I have to flip back and forth. It'd be nice if I could just put that little chart right here, but I don't. So look what we have. We have the side that's opposite the angle, and we have one of the other sides. Okay? So we have the side opposite this angle, and we have one of the other sides. So let's go and see what we have. First of all, we have an obtuse triangle, don't we? Right? Because what was it? What did I say it was? 105, right? And so it's an obtuse triangle. Now let's take a look at it. Is the A is the side that's opposite the angle. Is it less than the B, or is the A greater than the B? Do you remember what those numbers were? So is this less? This is my A and this is my B. This is greater than, isn't it? So go back to the chart. So the A is greater than the B. So look what we have. We have what? We have one solution. So if the side opposite this angle is larger than either this side or this side, okay, because they only give you one of them, they could give you either one. If this side is larger than either of these 2 sides, then you only have one solution. So that's kind of easy because it's just regular law of signs, just like we've always done. Let's go back to this, and let's just go real quick because there's really not anything real crazy and different about this because it's just one solution. We're good to go, and let's solve for everything. So what do you want to solve for first? In the other class, they said t, and I was starting to solve for t, but then I said, well, wait a minute, can you solve for t right off the bat? No, you can't, because you don't know the side opposite angle t, do you? So you need to know at least one of those. Yeah, so let's solve for s, right? So let's solve for angle s, okay? Now watch. Yesterday, we talked about either going A over the sine of angle A or sine of angle A over the side A, correct? It doesn't matter which way you do it. I have a preference. I would rather, the thing that I'm solving for, I would rather that be on top of the fraction. Wouldn't it be a lot easier to do it that way? So if I'm solving for angle S, how am I going to write it? I'm going to write the sine of angle S over what? Side S, which in this case is 6. Okay. Now we have to know the other two things. We have to know an angle and the side opposite that angle. So what are we going to write over here? Sine of 105 over 9. Good. And we can just solve for that. Multiply both sides by 6. And the sine of S equals all this, but how do we get S by itself? We take the inverse sine, that's right. I'll save the work and I've written it down already. So angle S is going to be about 40 degrees. Now for whatever reason, I rounded it to 1 decimal place. I think they rounded it to the nearest degree. I'm just going to use the numbers that I already did. Okay? Yes, Sean? Okay, now we have that. I'm gonna actually write that in the triangle so we see it. I'm gonna write it in a different color. I'll put a little arrow there because it's a little small. So it's 40.1 degrees. Now we can find this angle T very easily without even going through any law signs. How can we do that? That's right. I just do this. I say angle T. There's a couple ways you could look at it, but I like to do it like this. It's just 180 minus what? 105 minus 40.1 degrees. And so angle T is going to equal 34.9. Just threw that in a calculator. I didn't do it. It's not that hard. All right, so that's angle T right there. Now we need to solve for side T. Since we're solving for side T, I'm going to put that on the top. So it's going to be T over the sine. Actually, let me write that in the triangle I said I was going to. This is 34.9 degrees. All right. So it's going to be little t, right, side t, over the sine of 34.9 degrees. So it's the sine of 34.9 degrees equals, what can you use? Well, you could use the s's if you want to, right, because we know both of them. But I prefer to use the original information that they gave you because these are exact answers. The 40.1 is an approximation. I would rather use the exact answers that they gave us originally. So what are we going to put on top then? 9 over the sine of 105. This is just basic law signs, nothing fancy about this. Solve for t, multiply by the sine of 34.9. So you put the sine of 34.9. Cancel it out. Solve for t, just chuck that in a calculator, and I already did it, and it's 5.3, and that's side t. Alright, so that we knew we were only going to get one answer because we looked at that chart, right? And those are our answers. Now when I say one answer, I mean one answer for S, right? S isn't going to be anything else. It's only going to be that one thing. Angle T is only going to be 34.9. Side T is only going to be 5.3. And you're looking at it and you're like, well, of course. I mean, we did the thing. We did the law signs. Of course you're only going to get one answer. It's not always going to be the case, though. There are going to be situations where you're going to get actually angle S equaling two completely different angles, all right? And angle T completely different, side T completely different. We're going to do that last. Let's do another style of problem. All right, they give you two sides and an angle again, all right, but it's a little bit of a different situation. We don't have an obtuse angle this time, do we? All right, we have an acute angle. So we have to go to that chart that we had. It's in the book, or it's right here. Now we're going to look to see angle A is now acute, isn't it? So we have a couple different situations here. If it's acute, then if side A, remember what side A is again? It's the side opposite the angle that they give us. If it's less than H, what in the world is that? Yeah, it's the height. We didn't talk about that over here, did we? Okay, we have to compare the side opposite the angle that they give us to the height. So let's do that. Let's go back to that problem, all right, and let's find the height of this triangle. I'm going to do this in red. So it'll go from here straight down, and you'll see how the height comes into play here. And we'll call that H. Now, how can we find the height? Not with the law of sines, but now this is the height, so it's perpendicular to the base, correct? So we can use, it's now a right triangle, now we can use this and this. So what trig function is that? It's the sine, right? It's the sine of 54 equals the opposite over the hypotenuse. So it's H over 8 multiplied by 8 and h. You throw that in a calculator, and 6.5. For some reason I didn't write that in my notes, but okay, 6.5. Alright, so that's what the height is. Well, who cares what the height is? Well, let's go back to this. Well, I'll tell you what, let's look at this. What was our A? Our A is 6, correct?
Mhm.
And our height is 6.5. Can you remember that?
Yep.
Alright, let's go back to this thing. Look at this. What was the A? The A was,
6.
it was 6, and the height was 6.5, correct? So which one? Yeah, just looking at this, it's going to be no solution. Do you see that? All right. Why in the world is it going to be no solution? Well, let's go back and look at it. If you look at this, this is not necessarily drawn to scale. Oh, thanks. I better go to the next video.